So our next presentation will be Fungai Jani from the College of Worcester, Maria Tsakalakos. I'm so sorry. I was practicing so much from Emory University and Tseegi Nyamdorj from Smith College to present their work on betting in soccer.
So our project focused on analyzing the credibility of fixed odds betting on match outcomes in the Premier League, the English Premier League to be exact. So, hate to break it, but soccer is the most watched sport in the world, so the biggest sport in the world actually, with over 3 billion fans actually. And then now if you equate that to sports betting, so sports betting is now legal in 30 states in the United States. So that's a lot of people. That's a lot of people betting. A lot of people betting on sports. So 70% of sports actually, sports bets are from soccer. And what is the most popular league in the world? That's the English Premier League. So most of these bets probably focus on the English Premier League, and that'll be throughout the season. So 6.2 billion. Dollars in revenue in the 2021-2022 season. So that shows you that there's a lot of money being invested into betting. So that puts a lot of pressure on the odds and just the overall credibility of fixed betting odds. So our research goals. So we apply statistical models to Premier League matches to gain knowledge on the betting market. So we use betting data and also game level data, and then we building a comprehensive predictive framework for forecasting match results. And to make this, spice it up, we added metrics. So we added player evaluation and streak of the team. So streak, that's the form over the last 5 matches. And we focused on the Premier League 2018-2019 season, which showed a bit of stability. Manchester City had just won the league. They won the league before that, so we didn't include any of the seasons where, like, Leicester City, for example, had won the league. It wasn't going to happen again. So our data, the basic data, so you have the game level data with who won the game, the goals, expected goals, the home team, away team, past statistics, possession. Then we have the betting data, which we're focused on, which had the fixed betting odds for a home win, away win, and a draw. We focus specifically on Bet365. There are a lot of betting markets that will have different odds. So we specifically focus on Bet365. And then for our player ranking, we use FIFA. So those of you not familiar with FIFA is a video game, and it's released every year, and it'll have player rankings. So these player rankings are critically determined, and we incorporated this in our model, and I hand over to Maria to talk about the data engineering.
So we had our basic data set, which is just like your typical match stats for soccer in the Premier League season 2018 to 2019. And then we have our betting data. So we merged those 2 data sets together. It's based on the parameters of the names of the home team and the name of the away team, as well as the date of the matches. Each row represented a single match in this season. And so then we, after we cleaned out the data set, we also enhanced our data set by adding some variables. One of the variables was expect win, which was just like the how the betting data predicted the outcomes of the game. And we also, from there, we went to the expect points of the home game. How we computed this was we took the betting observations and we changed it into a fractional odd by doing 1 over that observation. And then we were able to sum up the bets from the home team, the away team, and a draw. And eventually we led us to getting a marginal probability and turn that into a %. And then from there, we were able to find the expected point by taking the % of the home team times 3, and then you're adding on the draw, the % of the draw. And we also did this for the away team. And then we have our full-time result, which is just creating dummy variables to help us through our analysis and our model. And then we have the difference between the home and away team of the expected points from what I just explained earlier. And then we have our streak, which is just the last 5 games. For each team, it was like the winning streak of the last 5 games in the season. And this was all weighed by historical data. And then aside from this merged data set, we had our FIFA ranking, as Fungai told us about. And this was just like the overall team ranking based on positions. So we had the rankings for each player, and then we like grouped them by their position in each team, and then we were able to get a ranking for the team. And then, so on this graph, we wanted to, before we did our analysis, we wanted to see the difference between the expected goals in our basic data set and our expected goals in the betting data set. As you can see in the basic data set, which is represented by the pinkish color, we had, it was like a normal distribution compared to the betting, which is more like skewed on like the home and the away. So this kind of led us to ask the question, like, do the betting odds predict the outcomes, the actual outcomes of the game correctly? And so our methods, we use a multinomial regression, generalized additive models, or GAMs, and then our random forest algorithm. We trained the first 2/3 of the data over the season, and we tested the last third of the season. And so for all three of these models, we started with a basic model, which was just the dependent variable, the actual outcomes of the matches. And then we also had our independent variable, which was like just your basic betting data of how they're accurately predicting the outcomes of the games. And then we would add the other metrics that Fungai told us about, which was streak and positional rating. And then CG will tell you more about the results.
Now that we built the models, we wanted to test the accuracy of each model by using Breer score. And Breer score is the equivalence of mean squared error applied to the predicted probability. So less the mean squared error, less Breer score, higher the accuracy. And if you notice here, most of the Breer score ranges from 0.25 to 0.27, and that is much higher than the average accuracy of match outcomes based on basic expected goals. And the best model, or the model with the highest accuracy, is a generative additive model with positional ratings and expected goals that we built from fixed betting odds. And even when we tested on like monthly based time series data, where we compute where we test the nth month by a model trained on all the months leading up to n-1 month, it still only varied by 3 positions, showing how even with like different splits, our model was accurate. Since we have know the Breer score, we wanted to show the actual representation of the model accuracy by using calibration plots. And calibration plot is a visualization tool, visualization of the disparity between the probability predicted by the model and the class probability by the actual data. So if a model is accurate, it should predominantly closer to the 45-degree dashed line. And if you're wondering why, the red line only has a short range from 0 to 0.25, it's because of the variety of draws in soccer. And it's important to note that in the 2018 to 2019 Premier League season, it actually had the lowest number of draws, specifically 49 from 380 matches. That is only 18.7% of the whole league. And the one on the right-hand side is the best model, or the model with the highest accuracy rate. That's the GAMS. And the one on the left is a multinomial-based model. And if you can see from here that the GAMS does a better job of predicting match outcomes, while the one on the left-hand side either under or over predicts match outcome when it's like lower than 0.4, or like higher than 0.4, because of how soccer is a volatile sport. Even if you have a higher rate of winning, you could still end up getting a draw or a loss. And on this side, this is the base random forest model, and just for to comparison purpose. And it doesn't really do a good job. It has type 1 and type 2 errors, and it shows how the GAMS model does a much better job of predicting match outcomes.
Okay, so the conclusions from our project. So betting data does create good predictions, And since we focus probably on the Premier League, it's very stable. It's just Manchester City winning a lot. So as a Liverpool fan, that's pretty depressing. But then that's probably why the betting data is probably easy for them to have the odds for the games. And while we added metrics, that created better predictions. So adding the FIFA rankings was really helpful. Team streak and expected goals from the basic data on the other hand overfit the model. That's why we had that squaggly model we had there. So yeah, next time you bet, please look at the betting odds and take your time to go through, or if you want, you could make a new model. Limitations. So there are some limitations in the project. We didn't include for like in-play injuries. That would definitely like decrease the chances of a team winning if their best player got injured. Unexpected tactical adjustments. And for example, like FIFA rankings are just at the beginning of the year. So these aren't like every week. So like the best player in the world, for example, might have not been the best player in the world last season. So his rating could be low. And in this case, that is the case for this season. So the best player actually was not that good last season, but now Jude Bellingham is probably the best player in the world. We have predictions from previous seasons. That will probably help, but in every season is different. 3 teams get relegated if you're not familiar with soccer, and 3 teams get promoted, so there's always 3 new teams. Every league is different. As I've mentioned, some leagues have consistent winners like Manchester City, but the Spanish league will have a bit more variety. 3 teams could win it anytime. And yeah, different betting websites as well could have different odds for specific games. So there's also that to look into. And lastly, we'd just like to thank Carnegie Mellon for having us today and for presenting, and Dr. Yuko as well. Thank you.
Thanks, guys. That was maybe the worst calibration plot I've ever seen. We have time for one question. All right, no question? We're good. All right, thanks again.